Imagine you have a messy pile of unsorted data and you want to organize it into groups. You don't know what the groups are. You just want things that are similar to be together. This is called clustering. Today we are mastering k-means, the most famous clustering algorithm. We'll look at the 4 steps and then we will see why where you start actually determines where you finish. So k-means is surprisingly very simple. There are 4 steps which we follow. The first is initialization. We pick k random points to be our starting center or centroids. Second step, we assign them. Every single point looks at the centroids and asks who is the closest to me. It then joins that team, right? After that, we update the centroids. When the teams are formed, the centroids realizes it's not in the center of its team. So it catches the mean average position of its member and moves there. In the fourth, we repeat the whole process of moving the centroids and updating it. Let's see an interactive simulation and understand how the things are going, right? So if I click on a random initialization, we have 3 natural blobs of data here. I've just dropped 3 random centroids right here. Yeah. Let me click again. Yeah, it's now look more nice. So there are some very random centroids I have drawn. Now, if I click on assign points, every dot color itself based on the nearest x, right? Look at the red cluster, it grabbing points from 2 different blocks. That is bad clustering, right? Like usually you can see like the upper one is capturing the red one, and this one is capturing the greenish one, and this is capturing a cyan color kind of thing, right? So it's not a great clustering method to do, right? When I click on the update centroids, here the magic happens. They slide towards the center of their new teams, and because the x moved, the points are re-evaluated. So what actually happens, right? Because the x moved, the points re-evaluate. And points things like, wait, now I'm closer to green x. They switch teams. And then if I update the centroids again, we repeat this assign update until blooms, right? So the x marks sit perfectly in the center of the blobs. We have converged. So you can see that there are some few red, could be outliers, right? Things happen sometimes. If we randomly initialize and create, yes, still it's kind of a algorithm bug. It's a very simple implementation of algorithm. Now, but there is a catch. K-means is kind of a greedy one, right? It climbs the nearest hill. If I hit reset enough times, I might get a bad initialization, right? Where 2x marks land in the same blob, they will split that blob into half forever, while the other 2 blobs get merged into one giant cluster. This is why model libraries use k-means++, a trick to ensure that the starting centroid are spread far apart, avoiding this trap, right? So k-means is fast and powerful, but remember, a bad start leads to a bad ending. Thanks for watching, right? So this was all about.